So in this video, we're going to actually take a look at finding zeros when a polynomial is not in factored form. So really, you can think of this video as just a factoring lesson. Now, we're all familiar at this point, hopefully, with factoring quadratics, but let's talk about what happens when we have polynomials that are not quadratics. So for example, well, let's just do this. We're going to look at 5 examples. And we're just going to find the zeros. And so really these are all just factoring strategies. So to start off with, let's look at this polynomial. Negative 3x to the fourth plus 12x squared. Now in this problem, we're going to use a factoring method that should always be your first choice. And that is to look for a greatest common factor, or the GCF. Let's write this out. Look for a greatest common factor. Just as kind of a reminder, this is the GCF. Okay, so let's take a look. 3 is divisible by 3, and 12 is also divisible by 3, so that works. And then we also have an x squared, and x to the fourth is also divisible by x squared. So in this case, we could say, well, the GCF is actually 3x squared. So what we're going to do is we're going to divide that out and put that out front. Now another thing I'm going to do is I usually don't like the leading term to be negative, so I'm also going to take out that negative sign. It's not the end of the world if you don't do that, but it's usually things oftentimes work out better if you also take out the negative. So let's take out a negative 3x squared. Now in this first term, I'm going to be left with just x squared because the 3's cancel, and then x to the fourth over x squared cancels. Remember, I am dividing by negative here. And so in the second term, the x squareds will cancel. 12 divided by negative 3 is negative 4. So I will be left with x squared minus 4. Now we're actually in a really good position. We're at a point where if we set this equal to 0 to solve for x, we can actually do that. We have the tools to do that at this point. We have x squared equals 0, which means x just equals plus or minus 0, but really that's just 0. And we could even say the multiplicity of this would be 2 because of that squared. And then we have x squared minus 4 equals 0, which we solved in one of the previous videos, and you end up with plus or minus 2. So the zeros would be x equals 0, x equals negative 2, and x equals positive 2. That doesn't look like an x. There we go. And the multiplicity would be 2, 1, and 1. So there's the very first example, and in this case, I was really just showing you all about this idea of GCF, the greatest common factor. All right, let's try another one. Now, a lot of these next problems will involve GCF combined with other tools. Okay, so here's my next polynomial, 2x cubed plus 4x squared plus 2x. Once again, the first step is going to be to look for a GCF. And so it looks to me like they can all be divided by 2 and also x. So we're going to take out a 2x. So let's rewrite p of x. We can write it as 2x. Now I'm left with an x squared, a 2x for this one, and then a 2. You could always double check, sorry, not a 2, a 1. You could always double check by distributing the GCF back in and make sure you get it. So 2x times x squared would give me x cubed, etc., etc. And so we would set this equal to 0. Now I have to set each factor here equal to 0. So I'm going to write x equals 0. Well, that's already solved. That's one of my zeros. It has one multiplicity. And then x squared plus 2x plus 1 equals 0. Now this is just regular quadratic factoring. We need two numbers that multiply to 1 and then add up to 2. So I would end up with x plus 1 times x plus 1. So I'm just using regular quadratic factoring here. And notice how I actually have x plus 1 twice, so I could rewrite this as x plus 1 squared equals 0. And so my 0 is going to be x equals negative 1, but it has multiplicity of 2. And so there's the solution to part B. In this one, we used the GCF first, and then we were in a situation where we could use our regular quadratic factoring. So don't forget about that regular quadratic factoring. All right. Now this next one is going to be a little bit weird. So let's go ahead and get into this. Let's do negative 0.5x to the fourth plus 3x. All right, so this one's kind of weird because of this negative 0.5 out front. Now there is a GCF of x, but another thing I'm going to do, even though it's not really the GCF, I don't like decimals in my leading term. So I'm going to actually include that negative point. I also don't like negatives in my leading term. So I'm going to include the negative 0.5 in my GCF. So it's going to be negative 0.5x. We're going to go ahead and factor that out of each of the terms. Now, as an aside here, in order to factor this out of 3, what you're going to do, it's kind of like what we did in the first one we talked about dividing. You're actually going to divide 3 by 0.5. You could do this on the calculator, or I guess you could do it this way and do 3 times 2 and you should get 6. Anyways, you should get 6. So let's go back to this problem now. So I have my GCF. I'm going to write that out front. I'm left with an x cubed for my first term. And I now have minus 6 for my second term. Now, just to double check, if I did negative 0.5 times, sorry, negative 0.5, let's do x here, times negative 6, notice that I would actually get 3x, which is what I started with up there. So this does work. So this is how you would factor decimals out. And we're now in a spot where we could find our zeros. We have x equals 0 again here. We also have x cubed minus 6 equals 0. And solving for this, we end up with... Now, when you do a cube root, you just get the cube root. So in this case, it's just the cube root of 6. Not super exciting. That doesn't reduce to anything. It just is the cube root of 6. There's no plus or minus. And, oops, I forgot to write the multiplicities. Multiplicity 1. It's also multiplicity 1 here. It's not like we have 3 cube root of 6's. That would look like this. X minus cube root of 6 cubed like that. It would be a completely different factor. It's just x cubed minus 6, and there's only one solution from that. There's not 3, and that one solution is the cube root of 6. Now, this problem was really more intended as an illustration of that decimal. So this is kind of the takeaway here is I don't like decimals in front of the leading term. I just realized I had a little typo there. Okay, so that's a lot of GCF that we did in those problems. Let's take a look at another one that actually won't deal with the GCF. So let's do r of x equals 2x to the fourth minus 11x squared minus 6. Okay, well, once again, I did just say this is not GCF, but let's take a look. Is there a GCF in this? No, 2, 11, and 6 don't have any. The 6 doesn't have an x in it, so we can't take any x's out. So at first glance, this looks impossible. However, it's not impossible. We're going to talk about how to solve it right now. Now, what I want to point out is this is what I actually call a quadratic in disguise. And the reason for that is I'm actually going to use a fact here that says x squared is x to the power of 2 times 2. So you multiply those two and you actually get x to the fourth. So I'm going to use this fact in just a moment, but I want to remind you of that over here off to the side. And really what this fact is x to the power of a to the power of b is just x to the power of a times b. So that's just a fact about exponents I want to remind you. So what I'm going to do is I'm going to sort of use a convenient substitution. I'm going to say let's let a be x squared. And so then that means that a squared equals x squared squared, which is x to the fourth. And so what I'm going to do is I'm going to replace x to the fourth and x squared with a squared and a. So I'm going to rewrite r of x as 2a squared minus 11a minus 6. Now you're probably wondering, wow, you can just do that? And well, yes, I can just do that because I clearly defined up here what a and a squared were. At the end of the problem, we will have to go back to our original and double check that everything works out. But you sure can define new variables if you want. A is just the variable x squared. So I'm making use of structure in this case. I'm noticing that this term here is this one squared. And so that's really why this is a quadratic in disguise, is because this first term, the leading term, is just the middle term squared. And then the last term has no x's in it. It's just a constant term. Okay, let's go back now to this part. R of x equals 2a squared minus 11a minus 6. This looks like a quadratic now. We know it's sort of a quadratic in disguise, but it does look like a quadratic. So let's use regular quadratic factoring just like we did before. So I'm going to multiply 2 times negative 6 and I get negative 12. So I need two numbers that multiply to negative 12 and then add up to negative 11. Those two numbers would be minus 12 and 1. Now we talked about a couple different methods for doing this. I'm going to do the factoring by grouping method. So I'm going to group those two terms and those two terms. Notice I split up that negative 11a into negative 12a plus 1a. If you've forgotten this, I do have a previous video on factoring that you can go check out. So now I take my two groups here, I find the GCF. And so I end up with this. Okay, so here's my factored form, but remember, we actually substituted. So now I have to go back and actually solve for x now. So we're going to go back and say, well, this is actually 2x squared plus 1 and x squared minus 6. But this is good because these are actually solvable. I set each of these equal to 0. And go ahead and solve. So this first one's going to end up being x squared equals negative 1/2. There's no, these are non-real zeros, so we're not going to worry about those right now. Just wait till section 2.5. And then over here, if you solve, you end up with x equals plus or minus the square root of 6. So I actually have two zeros. Each one has multiplicity 1 in this case. I know that they have multiplicity 1 because they don't show up. They don't show up in this format here. They don't have x minus root 6 squared, right? So that's the only time it would not have multiplicity 1 if you saw a factor like that. Okay, so that is the solution to that problem. We're all set with that. And then the last problem I want to do, I said we would do 5. Let's pick another letter. Let's go with a of x equals, let's go with x cubed plus 4x squared minus 2x minus 8. Okay. Now this one at first glance is another one that kind of looks unfactorable. There's no GCF to start with. It's not a quadratic in disguise. That would be the other situation. However, we can think about grouping in this case. So this is a cubic. So when you see a cubic, one of the options you should think about is factoring by grouping. And it works really similarly to how we did the previous quadratic, except it's almost easier because you don't have to do a step in between. You just take a look at the first group and the second group. A lot of times you can do this in your head as a quick check. Can I group these and get a solution? So the GCF for the first one is x squared. The GCF for the second one would be -2. Let's go ahead and factor those out and see what we end up with. X squared, and then I have x plus 4, minus 2, and then I have x plus 4. So notice how they each have an x plus 4 in them. So I actually end up with x squared minus 2 and x plus 4. Just like we did up here with that a minus 6 became its own factor, and then 2a plus 1. We have our two factors here. And so then going ahead and solving, we end up with x squared minus 2 equals 0 and x plus 4 equals 0. And so I now have all of my zeros. And so there are three zeros there, plus or minus square root of 2, -4, and they all have multiplicity 1. All right, so this video, like I said, just kind of turned into a heavy-duty algebraic finding the zeros, turned into a bunch of factoring problems. We can always review more factoring in class if you do have more questions on that. This is one of those skills that comes up over and over and over again, and it's easy to forget or easy to make little mistakes here and there. So please let me know if you do have questions